This is a video for MEI Core Pure Calculus 4 Integration Techniques 4.1 Further Integration using arc sin x. Let's have a look at this integral. You can see on the bottom line I've got the square root of a quadratic, and we already know how to deal with an integral that has a square root of a quadratic on the bottom. However, what's inside this square root is not quite the same as we've got here. We can, however, transform what we've got in here to get it into something which will fit this format. If we can do that, we know we'll get an arc sin x over a type of result. Arc sin, remember, is the inverse sign, and we might also see it as sine to the minus 1. We will use arc sin throughout this video. So here's an example. I've got an integral here, and I want to rewrite it in this form. So let's start with the original integral, 13 over the square root of 7 plus 4x minus 2x squared. And notice I've got a 2 here, and I really would like just 1x squared somewhere inside this bracket rather than 2, and I've got a 13 on the top. So I'm going to factor out both of those. So this is going to give me 13, that's factoring the 13 out from the top, and that's over root 2. This 2, as it comes out through the square root sign, becomes a root 2. The integral of 1 over the square root of 7 over 2 plus 2x minus x squared dx. Now, I'm just going to rewrite the bottom line there so that I get a minus x squared minus 2x inside that bracket. You'll see why in a second. Just make sure you understand why it's a minus 2x. And now this thing in here, I'm going to complete the square on this. So you'll see what happens with that. I'm going to get 13 over root 2, the integral of 1 over the square root of 7 over 2 minus, now completing the square for that, it's going to be x minus 1 squared. X minus 1 squared gives me x squared minus 2x, that's nice, plus 1, so I need to take 1 off it, dx. And so when I release that outer pair of brackets, I'm going to get 13 over root 2, the integral of 1 over the square root. 7 over 2, releasing the outer bracket means this is going to become a plus 1, so 7 over 2 plus 1 is 9 over 2 minus x minus 1 squared dx. And that's what I was looking for in the original question. There's that worked through, and you can see that pretty much follows the steps that I used. Technique was take out the factors so that we get down to a single lot of x squared, rearrange, complete the square, and there's our integral. So, continuing from there, I'm going to use a substitution. I'm going to let u equal x minus 1. So du by dx is equal to 1, and that means that when I come to do a substitution, I'm going to substitute du straight in for dx. So let's do the substitution then. I'm going to get 13 over root 2, the integral of 1 over the square root of 9 over 2 minus u squared du. Now if we compare that with our standard integral, that would be 1 over root a squared minus u squared du. We can see that this thing is in standard form, but with a equals 3 over root 2. So I can quote the result. I'm going to get 13 over root 2, carrying that through, and then I'm going to get arc sine u over a. Well, u over a is going to be u root 2 over 3, and I'm going to get plus some kind of constant. And now I need to substitute back in. I know that u is equal to x minus 1, so I can pull it back into here to give me 13 over root 2 arc sine x minus 1 times root 2 over 3 plus a constant. And so there's our worked through. The question really is, could I have done it without the substitution? I've used the substitution in here, but could I have done it without the substitution? Well, I've got du by dx equals 1, so I know that du and dx are just going to be substituted one for the other. If I look in the integral, I've got an x minus 1 all squared, and if I treat what's in the bracket here as just a single blob, then I've got 1 over the square root of a squared minus something squared. So I know I'm going to get an arc sine of that something here over a. And so with practice, we can actually miss out the whole substitution section, provided we are confident that we can handle the integration correctly. So in summary then, we took out factors to give a numerator of 1 and a coefficient of 1 for x squared. And in our case, that was taking out a 13 from the top line and a root 2 from the bottom. We then completed the square for the remaining expression, and in our case we were looking at x squared minus 2x, so we used x minus 1 all squared. And then substitute for the squared variable expression, and we used u equals x minus 1. Apply the standard integral, which in our case was an arc sine, and then reverse the substitution to get an expression in the original variable. And as we saw from the previous slide, we can actually skip the substitution. We can move straight from completing the square to performing the standard integral. The next video in the sequence is 4.2, further integration using arc tan x.